the two terminals on the screen, the left being a D message output, which is going to print out all of the messages that are printed from the kernel, and the second is where I'm going to be showing you how the user space application and the kernel work together to read the information from hardware and to publish it to the cloud. So I'm going to first load the module, and if I do that like that, as you can see that the module's been loaded, it initializes, it has a character devices, a struct class and a device class, and then it will interrupt the initialize the GPIO, which in this case is the magnetic sensor. It will create an interrupt and it will create a SysFS file. So the SysFS file is located in the sys directory. So if I do first ls sys sfs security door, there's a door state variable there, and if I cap that variable, you can see it's set to 0. So next I'm going to start my user space application. So if I start, this is what is used to communicate between the kernel, and it will also upload the device changes. It manages the display, the alarm, and it publishes all of the data to the cloud through IoT Core using MQTT. So as you can see, once that started, it printed out that the device file was open, and this is the task ID, which is registered in the Linux file system. So as you can see, I'm now going to change the door state on the device. As you can see, I did that several times. The interrupt occurred, so it sent a signal to the task, which was registered up here. And as you can see, that they received an interrupt signal, and then it published a new update. So as you can see here, the door state changed from true to false to true. This will all be uploaded into the cloud, which I'll demonstrate next. This is the device I've created. Pi0 is here, and it's connected just to a header. It just extends it onto the breadboard. So there's an ITC OLED display connected, which states the time, the ARM state, and the device ID, which is used to register on the cloud. That's connected with the I2C to these ports over here. There's also a buzzer, a magnetic relay switch, which is connected with a pull-up resistor to a GPIO, and finally a 9 keypad, which is plugged into GPIO pins over here. So the functionality of the device essentially is, as it says, it's disarmed now. The current pin is set to 555, so if I enter in a wrong pin of 666, this is the wrong passcode. Now, if I enter the correct pin, the 555, you'll see that it now says armed. So now what that means is, if I pull this, which is the door open switch, the alarm should siren, which you can hear now. To disable this alarm, you can't just put it like that. What you need to do is re-enter the correct code, where it will be disarmed. So I'm now going to demonstrate the web panel. So I'm going to start by going to the panel address, which is set to my own domain, and that should redirect us to a authorization page, which is powered by Cognito. So when we're on this page, we can just sign in, and as you see, I've already added a device. It should come up straight away. Once it's connected to the WebSocket, it should be able to do this. So if we go down, it says currently that we're not armed. So if we look down here, we're disarmed. If I press the arm button, and it should say armed down there. No, and on the web page it's automatically updated as well. So if I disarm that real quickly and then just show that that's that, and then if I quickly go back and just pull this off and wait a second,
and another second. It should say open now. This is a slight delay. As it's open now, if I click the arm button, you can hear that it's beeping. So I can then disarm that there. But also, if we wait a second for this to come back to normal, so as it's still open, I will arm it again, and we can also, once it updates, we can disarm from the website. Additionally, you can raise the alarm straight from the panel